Find an equation equivalent to r equals 5 over 1 plus cosine theta in rectangular coordinates. So here are the facts that you need. Here are the notes that you need to convert back and forth between polar coordinates and rectangular coordinates. You need to know that cosine theta is equal to x over r, and sine theta is equal to y over r, and tangent theta is equal to y over x. Now, this first fact can be written, if I were to multiply both sides by r, that would give me x equals r cosine theta. And if I were to multiply both sides of this equation by r, that would give me y is equal to r sine theta. So these are really just different ways of writing the same thing. Okay, now there's one additional thing that you need. R squared is equal to x squared plus y squared. Alright, it's basically the Pythagorean theorem. So using these facts, we should be able to convert back and forth. So, alright, looking at this equation, I'm uncomfortable with the fact that it's a big old fraction. So the first thing I'm going to do is multiply both sides of the equation by 1 plus cosine theta. So if I multiply by 1 plus cosine theta, that's going to cancel out the 1 plus cosine theta. So on the left hand side, that's going to leave me with r times 1 plus cosine theta. Alright, because I have the r and then I just multiply by 1 plus cosine theta. On the right hand side, all I have left is 5. Now, imagine that I were to do the distributive property right now. That would give me r plus r cosine theta is equal to 5. Now, where have I seen r cosine theta recently? Seems like we were just saying that r cosine theta is equal to x. So guess what I can do? I can replace r cosine theta with x. So now I have r plus x is equal to 5. So that puts me one step closer to having rectangular coordinates, which just only will have x's and y's, no r's or thetas. All I have to do now is get rid of the r somehow. Let's start by getting r by itself. If I subtract x from both sides, that's going to give me r is equal to 5 minus x. Now, the only way to get rid of r is to use this rule right here. I know that r squared is equal to x squared plus y squared. But I have r, I don't have r squared. So how about if we square both sides of the equation? Alright, what if I square this and square this? That should still be true. Let's see, I'm going to need a little bit more space. So remember that so on the left side I'll have r squared. 5 minus x squared means 5 minus x times 5 minus x. Now if I multiply this out, like double distributive property, that's going to give me 25, and then 5 times negative x, that's going to be negative 5x again when I do the inner parts, and then negative x times negative x is positive x squared. So that's going to give me r squared is equal to 25 minus 10x plus x squared. Alright, now remember the whole point of getting r squared was so I could use this rule. R squared is equal to x squared plus y squared. So I will now replace this r squared with x squared plus y squared. Okay, you might notice that I have x squared on both sides of the equation. So if I were to subtract x squared on both sides of the equation, they will both cancel out. So that's going to leave me with y squared is equal to 25 minus 10x. And that's it. We got rid of the theta and the r, and now all we have is x's and y's. So this is the rectangular version of this equation. So let's just look for it among our answers. So y squared equals 25 minus 10x. Oh look, here it is right here. Option D. So that should be the answer. Let's check it out. And there you go. So just make sure you have all these good notes written down and use them wisely.